Graphing sine and cosine equations. An in-depth look at using amplitude, frequency, period, and midline to graph functions. Before we begin, let's review a basic sine and cosine curve, and primarily our 5 main points. When we look at a sine curve, there are going to be 5 main points we will focus on. The point 0, 0, the point pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Those 5 points are going to be our key points when graphing any sine function. For the cosine function, our starting point is going to be different, although the points will be the same, just shifted. So we start off at the point 0, 1, then move down to the point pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, positive 1. It's these 5 points that we're going to keep coming back to and referring to when we graph each of our functions. One other quick note before we move on to the graphing is, in addition to remembering our 5 points, let's also quickly go back and recall our main parent functions in our standard form. If we were to take a look at, we'll do it with the sine function, for example, we have y is equal to a sine of bx plus c. With this, we know that our a value is equal to our amplitude, and that will give us our height of our graph. If we take the absolute value of our a value, I should say, that will give us our amplitude. If we take a look at our b value of our function, the b value is equal to the frequency and will tell us how many curves are completed between 0 and 2 pi. That's the general interval that we're using for that frequency, from 0 to 2 pi. Our period we get from our b value is equal to 2 pi divided by our b value. So that's going to give us how long it takes to complete one full curve. And the last part of this is going to be our c value, which is going to give us our midline and our vertical shift. Let's take a look at some graphs. Our first example, we have y is equal to the cosine of theta minus 1. Now remember, theta is just another way of saying an angle or an input or x value here. So if I take a look at this, I'm going back to my basic ideas of a cosine function, and my 5 main points are always in the back of my mind. Just from the graph, I can pull out that our amplitude is equal to 1 because our a value is equal to 1. Our frequency is also going to be equal to 1 because our b value equals 1. Now, when I write my frequency, I can say that there will be one curve in 2 pi. Another way to write this would be one curve every 2 pi. The period, remember, is going to be 2 pi divided by our b value. So our period in this case is just going to be 2 pi, which means that's how long it's going to take to complete one of those curves. And our midline is going to be our c value. So in this problem, our c value is going to be different from our parent function, and it's going to be y is equal to a negative 1. Now, let's go back to that parent function since I just mentioned it. If we have our basic grid here of our theta and just a basic cosine theta graph here, Going back to those 5 main values, at 0, our graph was equal to 1. At 90 degrees, our graph was equal to 0. At 180 degrees, our graph was equal to -1. At 270 degrees, it was 0. 360, it was back up to 1. Now, if I was to plot this basic curve of 1, 90, -1, back to 0, and back to 1 at 360, this is our basic cosine curve. However, because I have a midline that's equal to a -1, when I go to graph my cosine theta of -1, I'm essentially taking each of these values and shifting it down 1 point. So my point that was 0, 1, I'm now going to subtract 1 from that and get 0. I'll do the same for the rest of my points. I'm essentially just shifting each one down 1 place. So my new ordered pairs would be 90, -1, 180, -2, 270, -1, and 360, 0. And so if I plot these points now and graph and connect them, my light blue line represents my function cosine of theta -1. Let me go ahead and erase this so that I can actually see just our actual answer of graph here, so it's not as confusing. Now let's take a look at our y-intercepts and our range. For our y-intercepts, we're simply seeing where the graph is going to touch the y-axis, which is going to be right here. So we have one y-intercept at the point 0, 0. Now my range is going to be, what are the range of my y values? So from here, I'm looking from this point here to here. So it's these range of values for my y values that are going to give me the range for my function. So in this case, our highest y value is going to be 0, and my lowest is down here at -2. So I'd write the range with brackets at 0, -2, close brackets. If I take a look at our next function, y is equal to 3 sine theta, for this one I can easily start to go through and look for my a, b, and c values. In this one, my amplitude is equal to 3. My frequency, or my b value, is equal to 1. My period, which is 2 pi over b, would be equal to 2 pi. My midline, because there is no c value, is going to be equal to y equals 0. Now, again, I'm going to go back to my main parent functions, and if I was to take a look at my basic sine curve in those 5 key points for my input of theta, of sine theta, sine graphs are always going to start at the point 0, 0. And then from there, at pi over 2, you can see we're using radians now. I am at 1. At pi, I'm at 0. At 3 pi over 2, I'm at -1. And at 2 pi, I'm back up to 0. So those are my 5 key points that I'm going to be using here. Now, because my amplitude is changing by a factor of 3 here, that means the height is going to increase. Essentially, all we're doing with this is multiplying each of our sine theta values by 3. So 3 sine theta would become the function 0 times 3 is 0, 1 times 3 is 3, 0 times 3 is 0, negative 1 times 3 is negative 3, and 0 times 3 is 0. So those 5 points end up being my function 3 sine theta. So if I plot those, I get 0, 0. At pi over 2, I have positive 3, 1, 2, 3. At pi, and back to 0, negative 3, 1, 2, 3, and finish it off with pi over 2, 0. From here, I can connect my points, and I have my function graphed. Now looking for my y-intercepts and my range for this problem, I have my y-intercept here at the point 0, 0. And for the range, I'm going to be looking between my max and my min. What am I oscillating between? And in this case, I'm going between a positive 3 and down here at a negative 3. So I can write my range from negative 3 to positive 3. In our next graph, we can see we have a couple differences here. First of all, take a look at the grid. The grid has definitely changed. I'm going from a negative 2 pi to a positive 2 pi with my graph here. And this graph is our first graph where we have a different b value. So let's take a look and see how this changes things. So first of all, we have our amplitude, in this case, is going to be the absolute value of a. Here our amplitude is equal to 1, but we do need to make sure that we remember when graphing that we have a negative in front of this. This is going to be a reflect our graph over the x-axis. Our frequency in this problem is going to be equal to our b value, which is going to be equal to 1/2. That means there's going to be half of a cosine curve in 2 pi. The period is always going to be 2 pi over b, so that gives us 2 pi over 0.5, which is equal to 4 pi. My midline is going to be equal to my c value, so I get y is equal to 1. So, to start this graph off, we're going to go right back to those basic parent functions. So now that my table is drawn, I have my basic 5 key points here for a cosine function. The first part of my function I'm going to deal with is going to be that negative cosine theta. So that's going to reflect each of my points over the x-axis. So that means that my point 0, 1 will now become 0, negative 1. And then 0, positive 1, 0, negative 1. Now the next part that I have to take into consideration here is going to be this 1/2, that b value. So when I think about how that's going to be shifting my 5 key points here, is it's really just going to be stretching and spreading them out. So initially our graph was being completed from 0 to 2 pi. However, now it's going to take from 0 to 4 pi for that full graph to be created. That's what our period told us. So instead of from 0 to 2 pi like shown here, I'm going to change those values, and my 5 key theta values are not going to be 0, pi over 2, pi, and 3 pi over 2, and 2 pi. Instead, my first input is going to be 0, and my last will turn into a 4 pi. Now from here I need to divide these evenly with my intervals. So the midpoint here would be a 2 pi, pi, and 3 pi. So those would be my new 5 inputs for my outputs. So far we've taken care of our a value and our b value, and now we need to take a look at that final c value and how that's going to shift the graph. So our c value is +1, so I'm going to add that over here to our table and see how that's going to change our graph. Now remember, that's going to cause everything to shift. If I wanted to, I could at this point plot my points and then shift each one up like I did in the previous graph. But let's just use some knowledge here of what's going to happen and then say, okay, we just need to add 1 to each of our initial values, each of our initial output values here. So if I have my -1 value and I'm going to add 1 to that, that's going to give me 0 as my new output. If I was at 0 and I add 1, my new output is 1. If I'm at 1, my new output will be 2. If I'm at 0, my new output is 1. And if I'm at -1, my new output would be 0. From here, I can go through and plot my points. So my first point I'm going to plot is the point 0, 0. Then I have pi and 1. So at pi, I'm going to go up to +1. And at 2 pi, I'm going to be at 2. So 1, 2. Now 3 pi and 4 pi, unfortunately, are not on our grid, so I'm not going to graph any more to those on that side. However, remember this graph oscillates and it's periodic, so it continues to that same curve. So instead of moving to the right, I'm going to shift to the left side of my graph now and go over to -pi. Now this same pattern of points will continue to repeat. 0, 1, 2, 1, 0, 0, 1, 2, 1, 0. So if I worked my way backwards, at -pi, I should be at 1. And at -2 pi, I should be at 2. And now I can connect my points, and I have my full cosine function graphed from -2 pi to 2 pi. Now I can take a look at the final stage here, which are my intercepts and range. My intercept, I have one y-intercept here at the point 0, 0. And my range is going to be, what am I oscillating between? Which y values am I oscillating between? So this graph will oscillate between a max of 2 and a minimum of 0. So my range would be 0, 2. For our final graph, we have y is equal to 3 sine of 2x plus 4. So we can fill out our amplitude, frequency, period, and midline using our A, B, and C values. So I'll get an amplitude of 3, a frequency of 2 curves in 2 pi. My period is 2 pi over my B value of 2, so I get pi. My midline is going to be y is equal to 4. When looking to transform my parent function sine x, I'm first going to take a look at my amplitude here, which is going to be the 3. So for this, that means I need to multiply each of my initial parent function points, 0, 0, the 1, the 0, the -1, and the 0. Each of those outputs values by a 3. So I get 0 times 3 gives me a 0. 1 times 3 gives me a 3. 0 times 3 is 0. -3 times 3 is -3, and 0. Now I can tackle my B value, which is going to mean, which was a 2. So that means, looking at my period, that it only is going to take these 5 points to occur. These 5 points to occur not from 0 to 2 pi in our original parent function, but just from 0 to pi. So that 2 is going to change our function so that it's going to happen a lot faster in half the time. So from 0 to pi, my 5 points have to occur. So that means that my old pi point is now going to be pi over 2. And my old pi over 2 point, that old input, is now going to turn to an input of pi over 4. and 3 pi over 4. So those are going to be each of my new input values. The last piece I need to take a look at before I can plot my graph is going to be my C value, which is going to be shifting my graph up 4. So I can take each of these last output values that I have, the 0, 3, 0, negative 3, and 0, and I can add 4 to each of those values to get my final ordered pairs here. So I can take 0 plus 4 and get 4. 3 plus 4 is 7. 0 plus 4 is 4. Negative 3 plus 4 is 1. And 0 plus 4 is 4. So now I can go to my graph and plot my curve. So my initial starting point is going to be an input of 0 and an output of 4. So it would go over 0 and up 1, 2, 3, 4 and plot my first point. Now I am going to change my scale here quickly, and just because I see I have to plot a 7, each of these, instead of going by 1, these are each going to be 2. So that'd be 2, 4, 6, 8. So let's plot that point again. So now if I'm at 0, 4, I'm going to be here. Now my next point that I have to plot is pi over 4. So that puts me right between my 0 and pi over 2 and up 7. So that's 2, 4, 6, 7. At pi over 2, I'm going to be at 4. At 3 pi over 4, I'll be at a positive 1. And at pi, I'll be back to positive 4. So those represent my 5 main points of my function. From here, I'm just going to continue to oscillate. So I can repeat this pattern to continue graphing it from 0 to 2 pi. So again, I'm going to repeat from 4, I go up to 7, then back to 4, then down to 1, and then back up to 4. And the graph can continue. If I wanted to, I could continue into the negative direction as well, repeating the same pattern. From here, I'm going to go down to a negative 1, then up to a positive 4, then up to a positive 7, and back to a 4, and the pattern continues as the graph oscillates. For this graph, I have one y-intercept, and it's going to be the ordered pair 0, 4. And the range for my data, you can see my max is going to be here up at a positive 7, and my minimum is going to be down here at 1. So I can write my range as going from 1 to 7. Thanks so much for watching these two graphs.